It's time for another muzzle brake shootout, this time for 22 caliber. Gavin here from ultimatereloader.com. We had a lot of fun putting together our 30 caliber muzzle brake shootout. We took some 30 cal brakes we had around the shop, we put them on our Recoil rig, and we learned some interesting things, including the fact that bullet to brake bore clearance did not seem to be a key factor. In fact, we did a whole separate video with Salmon River Solutions exploring bullet clearance from 10th thou over bullet diameter all the way up to 0.2 inches over bullet diameter. And we didn't see a meaningful difference until we went from 0.1 inches clearance to 0.2 inches clearance. Not at all what I expected. And that's usually the case when I get out the Recoil rig. There's always a bit of a surprise. So let me introduce you to the brakes under test this time. We did the same thing. We took the brakes that we had a bunch from Ultragiant, and we had some other ones laying around, and we kind of put them all in a lineup. So in alphabetical order by manufacturer, we've got the Area 419 Hellfire 6mm/223. You'll see in a moment, it's pretty much the same as the 223 brake. We've got the Precision Armament M472 556. We've got the SJC 556 stainless. We've got the Ultradyne Apollo Max 556. We've got the Ultradyne Apollo S 556, the Ultradyne Mercury 5.56, and the Ultradyne Pulse 5.56. Okay, so that's these brakes in alphabetical order. And well, I wanted to start with bullet clearance because that's something that we can just measure right away with some pin gauges. We take the pin gauges, put it deep into the brake, and we find that minimal bore diameter, that most constricted area, and we kind of use that as the measure of what our bullet clearance is going to be. We take this diameter minus 0.224 inches. That gives us the total clearance between the muzzle bore and the bullet itself. And as you can see in this graph, we're hovering between 35 thousandths and 55 thousandths clearance over bullet diameter, with the SJC 556 being the tightest and the Precision Armament M472 556 being the loosest. And a little bit about our Recoil rig. So Cal over on the Precision Rifle blog did a great job putting together this scientific instrument that is called the Recoil rig. He built his one way, we built ours another way, but we used a lot of the same components and knowledge that he published on the Precision Rifle blog. We can capture rearward forces at the buttstock, basically what you're going to feel in your shoulder at 20,000 force readings per second. This is incredibly repeatable. This is really high-end sensors that we're using and data acquisition hardware. This is a great way to quantify instantaneous forces. Unlike a pendulum, unlike a sled, this gives you a real-time account of what happens. You can even see things like the ports of the muzzle brake in some cases. So this is what we're basing all of this testing on. Okay, rifle and ammunition. This rifle has been on the channel multiple times. This was the first rifle build that I did here on the channel. It is a Winchester Model 70, chambered in 22 to 50. Now, I originally had threaded the muzzle for 5/8 24. A lot of these brakes here are half 28. So I chopped off the end of the barrel about a ½ inch or so, 0.62 inches, something like that, and rethreaded it for half 28 so that I could directly mount all of these brakes. Now, the only exception here is that for Hellfire, the only taper adapter I had was 5/8 24, so we used a step up to take this half 28 to 5/8 24 and use that. Does not affect the performance of the brake in any way. This rifle, we did a recent story, is wearing a Boyd's Pro Varmint stock. This is a really great laminate stock. It looks better and it works better than the original stock that we had on the rifle. We've also got the Athlon Argos BTR Gen 2 8-34 by 56 scope. That was something that we featured in that Boyd's story when we did the stock upgrade. So we've got a lot more information about the rifle in those particular features. Okay, the ammunition was hand loaded by myself, brand new Lapua case, Hornady 52 grain hollow point boat tail bullet with the classic load, which is 38 grains of H380. A little bit of trivia for you. That is where H380 comes from. 38.0 grains for a 22-250, running approximately a 55 grain bullet. So I thought, why not go with that classic load? And 22-250 will give us a little bit more oomph to really test these brakes with. That was kind of my thought process. Okay, so we went through the process of installing each configuration, starting with the bare muzzle and then going through each of the brakes. And we captured the recoil data for each of these setups with this rifle and that exact load that I just mentioned. This is an apples to apples comparison. The only thing that's changing between each test is which brake is installed. Here's what we saw. As you can see, the blue line up here at the top is the bare muzzle. Quite a bit of recoil, peak forces around 300 pounds rearward. And take a look at what happens with almost all of these brakes. We're cutting peak forces down to the 100 to 150 pound range. Really drastic reduction in recoil. Pretty amazing results. And let me step through in order, and these are sorted by peak force observed each time, how things ranked. So the bare muzzle had the highest forces. Then we had the Mercury 5.56. You can see that's the sort of squiggly line there at the top. Initially, I'd wondered if this data was good because it's not this nice rounded profile, right? But look at how consistent things are. Each of these lines follows in descending order, and we have the same exact pattern repeating each time. That's telling me this is the material properties of the butt pad or some sort of resonance effect that's very, very consistent and very, very repeatable. So I went ahead and just used this data because it's good data. Okay, so below bare muzzle, we have Mercury 5.56. Then we have Pulse 5.56. Then we have the SJC 5.56 stainless. Then M472 5.56. Then Hellfire 6mm/223. This one says 6 on it. On the product page, it says 6/223. As you saw on the bullet clearance slide, it's running the same bullet clearance as the rest. So this is a great comparison here. Okay, working our way down in forces, Apollo S 5.56, and then the winner, the lowest forces, and you can tell it's by a fairly significant amount, is Apollo Max 5.56. This is more or less the same way that things played out in the 30 cal Brake Shootout. The Apollo Max 30 cal reduced recoil the most. Here's what's interesting about running this testing was there was only one brake that exhibited a noticeable blast. Now this could be partially subjective. When I put that SJC 556 brake on and pulled the trigger, I felt more blast in my face compared to the other configs. Now keep in mind I'm kind of above the rifle. I'm not in the exact position you'd be when you're driving the rifle actually shooting targets, but I just kind of thought that that was interesting. And I've talked with different brake manufacturers about that effect, the blast wave effect. Not something that we can directly capture with the equipment and the scientific setups that we have currently, but something that I'm thinking about because I think that's a key component of these brakes is how much do they beat you up over the course of shooting a varminting scenario like a prairie dog shoot, or if you're over in a PRS match and you're running through a couple hundred rounds in a day. There can be a cumulative effect, so there are definitely trade-offs there. Okay, so this is the raw data, and the raw data is sorted by peak force reduction. Let's take a look at some other visualizations of the same data and some other calculations I was able to run with the proprietary software that I wrote to analyze the raw data files. So peak force, this is going to be basically the same numbers that we ran through, but in the opposite order here if you go from left to right. So just under 100 pounds with the Apollo Max 5.6 and just over 300 pounds. So we cut peak forces in a third. That is pretty amazing to only have a third of the peak forces that you'd have with the bare muzzle. Totally, totally amazing. And then elapsed time, we had just under 12 milliseconds to just over 14 milliseconds of meaningful activity in terms of forces observed. That's 14 thousandths of a second on the high side and just under 12 thousandths of a second on the low side. So this is a very, very quick event, definitely. Let's talk about impulse for a moment. So peak forces is just the highest point on this graph. This was an example, I believe, from our 30 Cal Brake Shootout data. Now, sometimes we'll see some spikes, and so peak force might not be the best representation of what you actually feel. Impulse is the entire area under the curve. So it really captures, if you have a long push or if you have a short jab, your shoulder at the end of the day is going to be moving back at a certain rate, and the instantaneous forces are going to have a different feeling of sensation, but the net effect is proportional to and captured by this impulse number. So impulse is the area under the curve, and what I have here is a sorting of impulse from least to greatest. And this pretty much tracks with the peak forces as well, and you can kind of see that on the graph. Things kind of went down in general. Now in the middle here, a lot of these brakes are performing with similar impulse results, but you can definitely see that huge jump up when you go to bare muzzle. So all of these brakes do a great job at reducing recoil, but some stand out further than the others, especially Apollo Max 5.56. Okay, and then yet another visualization of the peak force numbers is the total percentage reduction. Again, we have 68% on the high side and just over 50% on the low side, and bare muzzle is not applicable because that's the datum which we're referencing everything else with respect to. So again, just another way to visualize the data. So this was a very fun experiment, and I always learn something new. Here's what we learned this time. Most of the brakes in this test dramatically reduced recoil, a lot more than we've seen as a percentage, both the impulse numbers and the peak force numbers compared to other calibers and cartridges, like 6.5 Creedmoor, for instance, or the 30 caliber. Apollo Max 5.56 and Apollo S 5.56 performed the best. Over 68% peak force reduction for Apollo Max 5.56. Pretty amazing. And also the peak forces and total impulse did correlate well. Again, in that middle category, a lot of the brakes performed very similarly, just with that anecdotal observation that I made around the SJC sending a bit more blast my direction. So what's next? There's a lot of different scenarios and tests that I want to use the recoil rig to capture data for. Things like, how does the bullet weight correlate to recoil? What about faster powders versus slower powders? This is something that you guys have asked for, and I know it's a factor. The question is, how much of a factor is it, right? And in terms of the overall test procedures, what about muzzle rise, which is directly affected by the compensation details, these compensator ports that blow the gases up to keep the muzzle down. We don't have a good way to capture that right now, but we do have some thoughts about some setups that we could put together. And then finally, sound level and shock/blast testing. This is a really difficult one. There are so many different factors. Sound is such a complex phenomenon that it makes it very difficult to really produce meaningful absolute results. But what I have the aim to do is to create a controlled environment and hopefully have controlled atmospheric conditions and run through a series of tests to at least get incremental changes and differences between different suppressors, different brakes, different rifles, right, with respect to sound level and shock. So just know that we are working on that. That's the other half of the equation. If we can get the recoil impulse and we can capture muzzle rise and we can talk meaningfully about sound level and shock, I feel like we've covered a lot of the bases that we want to. My question for you is, what other things would you like to see tested on our recoil rig? Drop a comment and we'll start a discussion. Thank you very much for watching. This has been a really fun video. That concludes this video, and that means it's time to wrap it up. I hope you enjoyed this video. Don't forget to like and subscribe. Also, we're on Facebook, YouTube, Rumble, where we've got unrestricted content, and Instagram. Make sure to follow us on all those channels. Ultimate Reloader also has a commercial solutions division serving law enforcement, the military, and the gun industry. We have some unique capabilities, including a comprehensive suite of recoil testing and evaluation capabilities, trigger profiling, and more. If you're interested in custom rifles like what we build here on the channel or gunsmithing services, you're going to want to go to rifles.ultimatereloader.com and get on the wait list. If you want to learn lucrative gunsmithing like what I show here on the channel, including building custom rifles and Cerakote plus a whole bunch more, you're going to want to check out the Colorado School of Trades, schooloftrades.edu. Thanks again for watching.